But as you start looking at like real life things, you'll find that not everything has a constant rate of change. Here we have an example. Here we have the average hourly earnings of people in the U.S. construction workers from 1980 to 2005. So in 1980, the construction worker on average earned $9.94 an hour. In 1985, they earned $12.32 an hour. So you can see we have like, what, $2.30 something cents change, right, over the 5 years. But then over the next 5 years, does it change by another $2.30 something cents? No, this time it changes by like $1.50, right? Okay, and then over the next 5 years, it changes by, like $1.30, and then the next. So what we have is something that's changing, but it doesn't have a constant rate of change. Is there a pattern to it? Well, somewhat. I mean, it is trending upward, right? I mean, from 1989, almost $10 to $12 to almost $14 to $15 to $17.50 to $19.50. So you'd expect that in 2010 it would have like 21, 22 maybe, somewhere around there, right? Now, what we're going to do in this section is we're going to look at how you can use a linear equation to predict something that doesn't have a constant rate of change. Yes, it's from the New York Times Almanac. See, so 1985 is 12.3. So if we think 12.5 is right in the middle between 10 and 15, so 12.3 is barely below the middle. 1990, we have 13.77. So that's going to be still under 15 by a little bit, right? It's not quite 14 even. So I'd put it probably, say, around here. Then at 1995, we have almost 15 exactly, so that's going to be pretty much right on the 15, right? And 2000, we have 17.48. Where's that go?
Right in that middle of 15.
Right in the middle of 15, 20. Right halfway between 15 and 20 is 17.5. 17.48 is pretty darn close. So right in the middle between 15 and 20. And then 2005, we have 19.46, which is pretty close to 20. So I'll put that one just a little ways under 20. All right. Is this a linear equation?
Yeah, not right now.
No, it's not a linear equation. Does it come close to being a linear equation? Yes. Okay, so what we can see when we do the scatter plot is that even though it's not a perfect line, if I drew a line through these 2 points, it's going to go up this way and it's going to miss those lower points, right? If I do a line through these 2 points, it might hit, it's going to miss that one, maybe hit that one, but it's going to miss this one down here, right? There's not one line that will fit these, okay? So the first thing we're going to do is make our scatter plot, and we're going to find some points and put those points on the graph. Then we do something called the line of best fit. Now, this is actually going to be easier for you guys because you guys can use like a ruler or a straight edge. But you're going to basically create a line that, while it doesn't go through every point, you're going to make the line that comes the closest to going through every point. Okay? So it's got to be a straight line. But, if you look at, if I go through these 2 points and I make this my line, is that a very good line of fit? Let me show it on the graph here. Let's say I just am concerned about hitting those 2 points. Does that come very close to fitting the data? No, okay, because even though I hit these 2 points, I'm moving further and further away from those points, right? And if we expect the trend would kind of be the same, we'd expect our next point to be around here and then here, and really this line's going to be too steep, right? So we want to find a line that fits our data in general. So I might make my line something like that. Now here's the important thing to know on this. The line of best fit that I make may not be the line of best fit that you make. This is not an exact science kind of thing because these are not actually linear equations, right? They're just something that kind of come close to resembling a linear equation. So my line of best fit looks like this. I feel like it's a pretty good line because I pretty well hit that point and that point. I'm just a little above that one, maybe a tiny bit above those two, but I'm pretty close to all of my points, right? So that's what we call our line of best fit. Thomas, question? Yes, yeah, I wasn't done yet. Yes, it is still a line, so it should still continue infinitely in both directions. All right, so step one, we make our scatter plot, which just means graphing your x and y's, putting those points on your graph. Step two, or still part of step one, and draw a line of fit. So this is our line of fit, okay? Now, number two, it says use the line of fit to predict the average hourly wage of a construction worker in 2010. Well, that's pretty easy because 2010 is where? Right here, right? And so I can simply look up at my graph and say, okay, that's right around here, which is between 20 and 25. It looks like it's a little less than halfway there. So if this is 22 and a half, that's probably around 22. So is it going to be an exact value? No, but this is a prediction. Since when has anyone ever predicted something 100% accurately? Predictions are not about getting the exact value. They're about getting something that is fairly likely. Based on the trend that we're seeing, that the money's going up, the pay is going up somewhere between $1.50 to $2.50 each 5 years, then we expect that it would continue to increase at that same rate, which means in 2010 we'd expect to see pay for workers to be around $22. Right? So that's what we're looking at with this information here is how do you use the line of best fit to make a prediction. Now, let's say, so based on that we could say 22 years is a pretty good, or $22 per hour is a pretty good prediction, right? But what if I wanted to go out and say predict what the hourly wage is going to be for a construction worker in 2035? Well, now you have two options. One option is you can stretch this graph way out and stretch the graph way up and continue to extend your line of best fit until you can get to 2035. Or the better option is we can write an equation for our line of best fit. Now, do we know how to write an equation for a line from a graph? I would hope so. You just took a test that involved writing equations from graphs yesterday, right? So we should be able to write an equation from this graph. Anyway, so what I'm looking for here is not that you got the exact same slope, but your slope should be something along the lines of that you're increasing by around 30 to 50 cents a year. Now, if you get that your slope, if it says, if you're multiplying x times 5, then it's going to be wrong because then obviously you have not calculated out your slope correctly. But if you're somewhere in that ballpark, that 30 to 50 cents per year range, then you're doing it correctly. So when I'm grading these, I am not looking for this is exactly what you should get. I'm looking for a ballpark. This is somewhere around. Now, how do we find an equation for this line? Same way as we find an equation for any other line. We start by finding the slope. So the slope is rise over run. I really need to get a new stylus. This one is falling apart. So slope is rise over run. There's two ways you can do that. You can either pick 2 points that look like they're on the line and, say, okay, from here to here, I'm rising about 5 and I'm running about 5, 10, 15, right? Or you can pick 2 points, like I'd say this point right here, circle it so we can see better. I'd say this point right here is pretty close to being almost exactly on my line of best fit, right? Also, this point right here is almost exactly on my line of best fit. Again, your line of best fit may be a little differently, so you might have 2 other points that are closer to being on your line. And I have exact values for those, don't I? Because I graphed them from exact values. This is supposed to represent 1990 and 13.77, right? So my y value would be 13.77. My x value would be 1990. Thank you. Then I also have this point. My x value here is 2,000, so I'm going to subtract 2,000 here. And my y value there is, at 2,000, it's 17.48, right? So I can do change in y's minus change in x. All right, we will continue this tomorrow. Make sure and bring your workbook with that page, and we'll continue doing notes on it. If you missed my class because you were test taking, go and watch the notes and fill out that part tonight.